interest. So, we are making the hand lens of a geologist obsolete, so to say. So we're doing everything with digital technology. That's the idea. There's an engineer in the tunnel who walks into and just has a camera, which doesn't mean that this person has to be an expert. So it can be an electrician who just gets a hand out of the camera and places it. So there's no geologist necessary on site, which makes everything much safer. And what you see underneath is a sequence of some products that we can get from these images. Now, the general problem is to characterize the whole environment. That can be in a tunnel to understand the mechanics, how these advances can go on, and where you have to blast and how much blast material you have to apply, but also for the evolution of another planet. So that's more or less closes the loop to the space application. And here we had solutions in planetary instruments, and that's pretty much the same. You have to do some geology and understand the surface. And the same applies to the formation and behavior of outcrops or other such formations that are formed by rock and sand. Now the technology is pretty simple and resembles more or less what the geologist would do. It's the eyes that are basically the cameras. It's the brains that's basically software that's doing 3D reconstruction, generates a data set, and this data set is being somehow analyzed by somebody who is an expert. And that's a software for 3D rendering and annotation. So we have some parties involved in that. So it's ourselves, which I am an expert in 3D vision processing. I do have 3D vision and space robotics team at Geoneum Research, which is a research entity in Austria. We have partners in Vienna, VRVs, who are doing the visualization part. And we do have already a commercial partner, which is DBIT Messtechnik, Measurement Techniques, who are providing these services in tunnels and also on rockfall areas and these kind of environments. On the other side, we have also scientists from the planetary societies, which is Imperial College London, who are doing this analysis on Mars data. So we know from them how to really design our methods. And of course there is the incubators and space case funding that we have to rely on. We have Andrea Kurz, I think, still with us today, who shared the prize ceremony with me yesterday. Now, there is a target market definitely in the tunnel, and we do have already a partner, so that's, I would say, kind of resolved issue. But there are also other application areas like tens of natural disasters, rockfalls worldwide that could be really profiting from this kind of technology. And we do have quarries, construction areas, dams, everything with kind of geologic formations that we have to analyze. Now, the benefits, the product is software, as we know. The customers I already mentioned to some extent. That's the tunnel building companies, but also the engineering firms involved in tunnel building. It's the geologists themselves, it's the service companies. And the real benefit is the geologist just sits in the office, doesn't have to go on site, and the on-site data can be somehow acquired by staff that is on site already. And we do have the obvious impacts on economy, like saving construction downtime, saving construction costs, because everything goes quicker. You save minutes per day. You have ecologic impacts because there's less environmental load, less fuel that you require, well-targeted protection means, and there's societal impacts, reducing the risk of staff. Now, coming back to space at the moment, of course we do have showcases. So our scientists from Imperial College, they continuously showing off these very nice and marvelous display results. They're sharing it with the public, and we are doing field trials, and of course there is some prospects that also the public can participate and get these 3D renderings and can manipulate themselves within the 3D renderings and do perhaps citizen science on the geologic results. So as I said, it's not that dangerous as it looks on this slide. Thank you.